Welcome to the April 4th demonstration. We were absolutely thrilled to have Jim Stevens join us from the Crossborder Chapter. Jim was impressive, sharing his expertise in sharpening and delighting us with his spindle skills as he turned a beautiful caddy spoon. He wrapped up by showcasing his faceplate skills, creating a square mini dish, inspired by Richard Raffan.
Thanks, Pat. Good morning, everybody. Good morning. I'm Jim Stevens. Easy drive down from Lisburn this morning. So first of all, I'll tell you what I'm going to do. These are a bit small, maybe on the screen, but my wood turning journey. I took up wood turning as a hobby about 20 years ago. After I retired from the day job, I joined the guild in 2009. I'm a member of the Crossborder Chapter, small group, and I learned the basics in those days by going to night classes, and we had a professional wood turner called Eric Turner. So we really went through the basics of sharpening, spindle turning, and eventually went on to faceplate turning. I spent a few days with visiting professionals. In particular, I had a week with Eli Avisera, a day with Jan Moreau, and a day with the late Mark Baker, and all those, I always learned something new from, and those professionals are always, they've got such a lot to teach us. The things that I like to make, I just like to make gifts, maybe heirlooms, maybe something your children or grandchildren will keep and say, he made that old fella, he made that. And then during COVID, we were locked down and I got onto turning these geometric shapes. And that thing has got a very fancy name, but there's 62 faces on that. And so it's ideal if you're got plenty of time. So what are we going to do today? We're going to cover sharpening, a spindle project, and a faceplate project. In sharpening, I'll show you how I sharpen on my system, which is a hybrid system. For faceplate, we'll turn a caddy spoon, for spindle, we'll turn a caddy spoon, and faceplate, we'll turn this wee dish. Now, so there's nothing new here, nothing that you haven't seen before, but hopefully, and maybe in the way I do things, you pick up some tips. So these caddy spoons are turned often by Phil Irons, and he did them whenever he was at maybe Monaghan, was it? In the seminar in Monaghan. And Richard Raffan recently has shown us how to turn these little square plates. So just in a sharpening system, I got bogged down in sharpening, and I've ended up with a real hybrid system. But the things to remember about a sharpening system, you need a coarse grit to shape new tools or to repair damaged tools, and then you need a fine grit for routine sharpening. And mostly whenever we get our tools shaped once, then that's it. All we want to do is sharpen them. So in sharpening, tools are expensive, and we don't want to turn good gouges and chisels into iron filings, so you want to remove the least amount of metal possible. So the sharpening system has to be convenient. You can't say, I'll wait, I'll sharpen it tomorrow. You have to sharpen it as soon as that tool's dull. And the sharpening system needs to be repeatable to prolong the tool life. And the old adage is, if you can see an edge, there is no edge. So if you look at the tool and you can see the edge, then there is no edge. So I realise these are the images are maybe too small on the screen, but the key thing is the difference between a sharp edge and a blunt edge is reckoned to be 1 thou. Now, a thou is a thousandth of an inch. We used to be used to inches and talk about thou whenever you were setting the points in a car, or setting spark plugs. But now thou is an old term, and we're on to millimeters and fractions of a millimeter. Just to give you an idea, the smallest feeler gauge that I could get was 2 thou, and if you look at that with a sharp light, you have no trouble seeing the edge. So if your tool has got a 2 thou edge on it, it's blunt. It's very blunt. You need to take a torch and look at the edge, and you can clearly see the edge. So the whole idea in sharpening is to remove about 1 thou of material. And 1 thou is 25 microns, whenever we come to sharpen scrapers, the little burr that you turn on a scraper is reckoned even less than 1 thou. So if you can get it right, you don't need to waste too much steel. Numbers that we're referring to all the time whenever we're thinking about abrasives. There are 2 scales. There's either grit size and abrasive grade. Now, grit size, that's the size of the particles that go in to make up the abrasive. Abrasive grade is just the opposite. Take an example. That grit size there. That grit size is about 269 micron, 10 thou. That is what's in a coarse wheel. That's a coarse wheel. And then to go from blunt to sharp, we want to remove 1 thou. So we need to move away up the grades, away up until we get to 180. So the coarse wheel is a 60 grit wheel, 60 grit P60. The particles on that are huge. This is a fine wheel. It's reckoned to be 180 grade, so the particles on that are supposed to be about 3 thou. So a very few passes of that wheel in front of your gouge will make it sharp. So we don't want to waste. And once you get up to a red diamond file, these and a red diamond file, 25 micron, you'll see the professionals going around the edge of the chisel and you go from blunt to sharp. Well, 25 thou is 1 micron, so they're only removing a very small amount of material to make their tool sharp. Remember that all abrasives are particles embedded in some sort of matrix, and that's, if you can get down to looking at abrasive magnified, you can see the grit particles embedded in there. That's we'll skip that. So what I've ended up with is a hybrid system. I wouldn't start here now. I'll describe it as as we use it, yeah, I would start somewhere else. Let's get on to today's demonstration. We'll do a little sharpening, we'll turn the caddy spoons, and we'll do a faceplate. That's what's going to happen today. We'll cut that way. So, a caddy spoon. We start off with a block of material like this here, and I have this one. You can do it all in one and then cut it down the middle with a bandsaw, but I have glued these two pieces together. I have glued these two pieces together just with a paper joint. So the first thing is we want to put a chucking point on this and get it into the chuck. But before we do that,
What's the tape?
sorry?
The tape on the block.
Oh, that is just in case. They have never.
Insulating tape.
They have never split with me before, but there's always a first time. So I'm only going to put a chucking point here and reverse it, and then the tape goes. So before we go and hit the go switch, think about safety and the acronym SAFER, safer. This way.
Yeah.
Is that your way?
Yeah.
Okay. You shout, and if there's any questions at all, just shout. So I'm relying on Mike to keep this in focus. Safer, speed. Get the speed right. If you're not sure about the piece, turn the speed down. Aside. If it's a big chunk of wood, a big chunk of faceplate, stand out of the way when you hit the go button. Fixings, make sure everything is locked down. Eyes. For this project, I'll wear safety glasses whenever we come to the square plate, because I might chip a corner of it. I'll have to wear the shield. And then the final thing before you hit the start button is to give the thing a spin so that you're not going to smack against something. At home, what would I wear? A lot of these things, eyes, face, lungs. I would wear a power cap. A power cap which pumps in filtered air. I wouldn't wear ear defenders, it's not that noisy, and I do wear anti-vibration gloves. So, first, they're just padded. The gloves are just padded, the palms are padded, and it's because I've got a problem in my hands. I've got a problem with a condition, Dupuytren's contracture it's called, whenever your fingers bend in. So, the first tool, spindle gouge, very simply sharpened on this system. See there? either like that or on the platform. What the two I would normally use the arm, the one-way system. If you were buying this as a professional system, this would be called the one-way. This is a piece of curtain rail or wood. You spend a fortune on sharpening systems. So the only thing to remember when sharpening this gouge is it is not a full semicircle. Therefore, you don't go totally closed. If you go totally, let's say this is the 93 position, you don't hold the gouge totally in the 12 to 6 position because you'll cut away the edges, cut away the corners. And usually in a roughing gouge, you don't want to do that. So you just swing it until it's maybe at 1 o'clock, 7 o'clock, and the other way. Okay? So we want to put a chucking point on here. Just take a The second tool we want to use is the parting tool to put a dovetail on this jugging point. I quite like sharpening these parting tools flat on the tool rest. So this tool rest will be set like that, and then sharpen one side, turn around, sharpen the other side. That gives a slightly hollow grind whenever you look at the tip of this tool. Whenever you look at the tip of this tool, it's got two sharp points because it's been sharpened on a round wheel. It's good for deep cuts. We can afford to take a little bit more off there. A little better. It's that little gizmo there. I didn't want to use the sharp point in case it broke the joint apart. So that's a little fitting that turns your standard 60-degree point into a cone center. The worst thing about it is you keep dropping it, and that's why I made a little carrier for it so that it kind of holds it onto there. So you need a long bar for this video, don't you?
This one is.
Oh, there's one there. Oh, that's it. Thank you. The jaws and the vic mark are dovetailed. So now we can get rid of the black tape.
Jim, did you say you put a piece of paper between those?
Paper joint, yeah,
With just wood glue?
wood glue. Okay, right, bring the whole thing now to the round. And square up this end. Now, what we want to do on this end is make a perfect sphere. So let's use the octagon method. In the octagon method, a sphere, a circle, sits inside an octagon. 8 sides, 1, 2, 3, 4, 5, 6, 7, 8. So what we're going to cut, we're going to cut away the corners. We're going to cut away the corners, and once we've got cut away the corners, we've removed most of the waste wood. So, a simple calculation, this is going to be the wrong way around, 141, 41.4 there. If the radius of your, sorry, it's the diameter, if the diameter of the sphere is 100, the octagonal side is 41. This one here, this one is 200, so that octagonal side is 82, right? That is 200, so that's 82. The ratio, 100 to 41 is the ratio. So what we want to do now, what we want to do is to measure what diameter have we got? We have got 51. We could make it 50, but there's no real reason to make it exactly 50. So it's 51. So I have a calculation sheet. If you have 51 multiplied by 0.41, that means the octagonal side has to be 21. Set 21 on a pair of calipers. this here is going to be one octagonal side. So make this one 21. Okay. Do you need more light over here, Mike? Do you need?
No, I didn't.
Does that help? No? Worse? So mark, this is the diameter, so the sphere has to come to here. We want to mark the middle point, 25 and a little bit. And we said the octagonal length was 21. 21. So from that center point, make a mark so that there's 21. That's the center point. That's an octagonal side. Oops, a bit rough. And we make an octagonal side in here. So there's the equivalent of one octagonal side on this spigot. There's one octagonal side here. So let's get rid of the waste. Spindle gouge. This is waste. And we now have definitely got to get rid of. Get rid of this. Got to get rid of this waste. And screw chisel. So this tenon in here is one octagonal side. That's number 2. That's number 3. That's number 4. That's number 5, 6, and 7. So 8 sides to this thing. We've got to the stage that we've got rid of all these. Got rid of the big corners. Got rid of the big corners. So we just need to tidy this up a wee bit and get rid of a little bit more waste. I'll mark this in red, even though you probably wouldn't want to mark it in red, because the red may not come out. And the first 2 lines I mark are going to be on the sphere. So that's going to be on the sphere, and that's on the sphere, and that's on the sphere. The waste that we're going to take out is this wee bit of waste here, this wee bit of waste here, that wee bit of waste there, and a bit of waste in there. So once you get that cut out, take a little bit of waste off here. That should be the basis of the sphere. Then it's a matter of tidying it up. I'm just using the long wings and this spindle guide to scrape. Bump here. And how do you know if you've got a sphere? One way of doing it is a circle will always fit in a circle. So if you have something like a copper olive, that's pretty true. And that doesn't fit too well, so that's not too good a sphere. There's a bigger one. It's getting there, but it's getting there. And then the way the professionals do it is I mark this, coat it with my soft pencil, and then the professionals take a hole cutter. One of these things, the teeth have been cut off. Don't try it with the teeth on. The edge that's doing the cutting is obviously the inner edge of this tool. So I'm no expert at using this, but I've watched others doing it. The only way I can get this to cut at all is to sharpen it just flat on a diamond hole. So we'll try it and it'll make an ugly noise. It's not totally round, so I think it works better if you spin it slowly on the drill. How many people have used this? Yeah, it'll work. I'm spinning slowly. And you can keep it. If you don't rotate the drill, it'll tell you where the high spots are. So there's obviously a high spot there, another high spot there. If you spin the drill, you can sometimes get it to cut. So at least it marks the high spots. And it brings that nearly, or near to a perfect sphere. We'll finish it off just with a take off the high spots with a scraper. A bit of a bump on the end. That's a negative rake scraper, in other words. It's got a facet along the top and a sharpened edge, just sharpened on the grinder. It doesn't look too bad as a sphere. You need a different scraper to get out of it. Something shaped so that we can get right in here. We're going to call that a perfect sphere. I won't sand it to create all the dust, but in sanding a sphere, it's a good idea to use sandpaper where the center is relieved so that you are not sanding on one place only. So cut slots in the sandpaper. So that the wrong way. So it fits around the sphere. Just rather than using it like regular sandpaper, because you probably cut tracks in it. We'll say that's a good enough sphere, and then all we need to do now is make the handle. And the handle can be any size you like. There's a lot of waste there. So get rid of a lot of this base. With the handle and cut a nice smooth curve, and that's where a continental spindle gouge is good for cutting long, smooth. And at this stage it will be sanded and then pour it on and then sand it. Skew chisel. And then the moment the surface can be split. Set it on a little grilled. Find the joint. This is just a blunt edge, not a very sharp edge. You can't use a sharp edge. We end up with two half. Now, okay. All we need to do is hold that. There's a spindle rod. How does the spindle rod on this layer work? This one. Yep, thank you. So to hollow, you need some way of holding it. If you're only turning one-offs, then you would just use a jam chuck. But if you're going to turn many of these, it's worth making wooden jaws. So these plastic jaws that are made for this chuck, they're not deep enough, so they needed a bit of an extension screwed on them, just made out of plywood. So you can do multiple paddy spoons of various sizes. So just make sure that it's going to fit in there nicely. It's going to fit in there, and to be sure, we'll go for a wee drop of hot glue. So we have to be quick once this glue gun's warm enough. From your friendly local dealer. Right. 1 spot, 2 spots, 3 spots, 4 spots of glue. And get it fitted into place. Just like that. Don't tighten it too tight, because remember, we're going to hollow this. And if it's too tight, it might smash it. It might smash it anyway. Just in case this handle flies off, more tape. At this stage, we can see how good a circle we've got. So pick a wall thickness. Not quite sitting right in that. See, we're not getting a perfect circle. I probably can't move it now. Well stuck in there. Anyway, it won't come out. It's worth drilling a depth hole. So that sphere was 51. That should be 25 thick. We say a wall thickness to be sure of 5. 20. We drill in 20. Could move a teaspoon. And hollow it down with a bowl gouge. The bowl gouge is maybe about 45 degrees on the nose, well swept back, sharpened using this jig, a wood cut true grind jig. It's the most versatile one that I've had. I started off with still have them, of course. Started off with sorbet jigs restrained in the sorbet system. Tried the long grind. All these, that fits some bowl gouges. Whenever it comes to sharpen, if you want to sharpen a big continental gouge, big continental spindle gouge, that doesn't fit in there. I ended up made one of these.
Is that a copper pipe?
Oh, it's just a copper pipe. Made a copper pipe. You can't put it.
Sorry, Jim, when you made a copper pipe after, did you then use it on the sorbet system?
We use it in this system. Doesn't work in this way. Well, it was, yes, it will fit the sorbet system, but you can't get the grind you want on the sorbet system. That's That's the problem. Sharpen a skew chisel the way I wanted to sharpen a skew chisel. I made this jig, which is okay. The skew chisel will fit in this jig perfectly. And well, let's sharpen this, show you how we sharpen this bowl edge. Paint it red. I have made it both sides. So, if the thing's going to get rid of the platform, whole gauge, half inch, 45 degrees. That's basically the right right. And that spacer, that fits in this little hole. You bring it up to a mega track. Perfect. Perfect.
Jim,
Pure up.
if you're trying to replicate the lines, is it important to have the protrusion
yes.
that's coming out?
Protrusion is set on that one square block.
Okay, yeah.
Every one the same.
Yeah.
So all we do to show is we need to remove very little metal. Bring this thing up to speed and switch it off and put enough momentum. Go to one side. Right in the middle. Bring it up to speed. Switch it off. And that's it. And then I cut back the heat. That's what it takes. If you're standing scrubbing the chisel from side to side, you're just creating iron filings. It's good for the tool manufacturers. We've only got 5 minutes, but the key thing about I only bought this before Christmas because Axminster are the agent, and I think this is maybe an old model, but they discounted it just before Christmas. I've looked at it for a long time. I've spent a fortune on sharpening gear. This thing holds a skew chisel perfectly. We've only got 5. We need to get this thing hollowed. So again, the protrusion has to be set 50 mil. This setting has to come round to nearly straight, nearly straight. And then what happens is, I haven't got this properly fixed. When you come to there, and you have the chisel sitting straight across, and it's set so that you're getting it's cutting on the edge, And whenever you sharpen the edge, then what you do is you push it up the edge like that. You push the tool up the way, maybe only the level length, a centimetre no more. And that turns a hollow grind into a convex grind. A hollow grind skew chisel for an amateur is just too aggressive, too hard to use. But a convex grind skew chisel is a dream to use. It is so much easier. So all you do is sharpen the edge and push the tool up the chisel. Push the tool up the blade. That simple motion makes all the difference. And this true grind jig, this is made by the New Zealand folk. Woodcut. This is by far the most versatile jig that I've seen.
Do they have a whole assembly system then? Like you've got a homemade system there. But do they sell, people who sell that grip, do they sell the whole system?
Oh yeah, it just costs a
You've
fortune.
adapted the suit then?
The woodcut platform, their sliding platform, and they about this part as a separate attachment, but it falls away whenever you don't want to use it. It's a beautiful system. It's such a huge price. So. Pat, is it it's tea time, is it, Pat? Must be close. Well, the idea, so you got to stop this chisel from shooting back. I'm not sure how much you can see, maybe you can see. So the entry point has to be, oh, look at that.
Jim, I think your sound is unplugged. We can't hear you. Might be the back.
Here, well, oh yes, you've gone. Right, all I'll do is just finish couple of cuts here, and then it's tea time. It just depends on how thin you want to go. Maybe a bowl scraper just to... And there is room in here to use a wee gauge. If you had it set right, there's room to use a wee gauge to judge your thickness. It's not far wrong. And if there's a lot of torn grain in there, you might shear scrape it with a wee round shear scraper, and this particular one has got the burr put on it with a burnishing tool. So burnishing tool. So just sharpen it, and then run this burnishing tool a few degrees off the bevel, but it doesn't take a huge pressure, about as much as peeling a potato, not a huge amount of pressure, and that might allow you to go in and do a little shear scrape in there. Detail. Sometimes the glue holds too tight, so a wee squirt of methylated spirit.
Right, Jake, we're ready for tea whenever you're
Yep.
ready, okay? We're ready for tea
Yep.
whenever suits you.
This glue takes a serious grip. There it is.
Just to remind you that on Wednesday we have a demonstration here in the afternoon. Now numbers have increased a little bit, but we'd like to be more. Okay? So as many of you come along on Wednesday. What's the demo? That I'm not too sure of. No.
Do you really want placards?
You tell us you want to. We'll be here on Wednesday at 2 o'clock, 2:15. Yeah. Okay, thank you.
Thanks, Pat. Right. We're going to turn a square plate. The reason we're turning a square plate is because I got given a lot of oak offcuts that were 25 mil thick, and I didn't know what to do with them. And then I saw Richard Ralphin turning square plates, and I never did get a set of square plates turned, but the challenge would be to make, say, 6 square plates that were all the same. And every one of these is slightly different. So to make them the same, we need a template. We need a template for the base and a template for the center. So what's the governing factor in getting a template? Well, it takes, say that this is a square block, it's a 100 mil, 25 mil thick. So what sort of template do I need to make? And I've only got that thickness now. slide. Well, the only template that I could come up with was one that was a perfect circle. So you can do this manually by judgment. Just have something there to center the compass. And let's say we want the template that has to cover the diagonal. So you make your calculations on the diagonal, not on the side of the square. So if we were going to say have a wall thickness, this here, that's 25, and we were going to have a wall thickness of 5. So we want to something like that. So what sort of radius does that need to be? It needs to be 135. You can do it. You can do it by trial and error, or you can do it on an app. On your phone, an app is called ArcCalc.
What is it?
ArcCalc. Right? And you only need to know 2 things about a circle to be able to calculate all the rest. So in this case, we know that this length here is 141. That's 100, that's 100, so that's 141. That's 141. Just so I get it right. And since this piece of wood is only 25 thick, and if we allow 5 for a spigot, and so we're going to say we want an arc that has only got a height of 20 and a width of 141. If you put in the width in there, is 141, and the height is 20. Oh, sorry, not 28, 20. And hit calculate. Which way around is best? Is that way around? The radius of the circle, not now. The radius of the circle should be 134.25. So either use ArcCalc or use trial and error. If you had a much bigger piece and needed a much bigger arc, then you'd have to go again, and maybe you would need a big arc, and say something about way out to here and out to here. So once you know the radius, well, that is the easiest thing to do. To print out the template on a printer, which is what I did, and then stick it onto a bit of plywood, so that eventually you end up with 2 pieces. Then take that sheet there. There's some other information up at the top of that sheet that relates to spindle turning, but we never got to that. now that we've got a template for the bottom and a template for the hollowing, we can go and make a dish, make a mini dish.
Jim, did Richard Raffin do that calculation on his YouTube, or did he just turn it?
Oh, he just done it there. He's probably turned thousands of those things. He doesn't need any aids. I don't think. So we're going to make this thing on a screw chop, but far too much screw here, so spitter, maybe another one. And we're going to put a little tenon on here. This is the base. So we want to cut the base. We want to cut the base so this thing fits it exactly. Take one of the jaws. The tenon needs to be 50. This little gizmo here, I'm measuring from point to left-hand edge of roller bearing because I let the point, the right-hand point, catch once, and I thought to myself, there has to be a way to stop that happening because it's a safety risk letting that point catches and that flicks out of your hand. It's too dangerous. So in this case, let's here. Whenever it comes to turning these corners, if a corner flew off, it might be not be sharp. So, make a scratch, that's too big. Make another scratch, watch the left hand side of the roller bearing. That's just there. The roller bearing can touch. That's the wood, no problem, doesn't take. So, Now, you've got to shape this thing. I think the chances of breaking out the corners is less if I cut from outside towards the centre. And there's a lot of area to be cut, so I probably need to turn it. Sorry, Pat. Okay. The mass is speeding up as well, fast, but with the banking glasses. Since we're cutting so much air, we probably need a little speed to move from the outside. And the ultimate aim, of course, the ultimate aim is to have to fit this template. So there's wood to come off somewhere.
What gouge is that?
That's just a bore gouge. About 45 degrees on the nose. Well cut back. So what we need to leave, we want to leave about 5 mil here. We want to leave about 5 mil here, so that's probably enough off there. But how's the template looking? And then you must use the template across the diagonal. So you can see, you can go from a situation where you think this is never going to fit until you suddenly think I've taken off far too much. Which is very nearly the case. So I actually need to take off a little bit more in there, in the middle, which is very small amounts make a big difference. See, nearly there. And all that. The one this. You'll see that's close enough. That's ready for some sort of finishing job. A negative rate scraper. Without a negative rate scraper, we'll finish this base okay. Make sure that that's good. Next option will probably be shear stripping. Shear stripping, handles low. This is just a bit of steel with a grinder burr on it. So let's go there. Be dragged across the surface. The shear stripping is the latest of touches. You're not, you're just pushing the surface. The angle, of course, has to be less than 90 degrees. So it's the ball that's cutting. Looks good. Would sand, we won't sand it.
Would you sand that by hand, Jim, to make sure your brain is right?
I would just sand that. And just take that thing there and put a square on it and do it by hand. Because you're only going round the edges. I hope we haven't got this too late. Just right. I do like dovetail jobs. They really, yeah, to me the dovetail jobs are just far superior to now, the tricky part, you can't bring up tailstock support. Just in case, until we get these edges cut. Just in case we get a dig on and the whole thing flies off. Same whole gauge. We'll leave the weight in the center until we get the critical part done. So, get a view of it. Take a look. Thicker in the middle and the outside. So we need to go in at a steeper angle, take another cut. Here's the hole here. There's a bit of magnet there. I wonder what was turning. See the edge? Okay. Looks like now we'll leave it at that thickness. I'll wait a bit more. So we can get a gauge. Yeah. Okay, down there. Close. Now look. We have to get rid of the tail stop now. cutting back this way, there's less chance of you kicking it off the chop. And now we need the second template to see how we're getting on. Wow. Was that lucky or not?
Oh, skill.
That was sheer luck.
I know it's good.
Sure script.
You got that one, Ken?
What's there?
You can't stand it now.
And there is a wee bump in there. And there's a little bump right there. Now it's time for sanding. And again, right towards those edges I would sand just manually rather than risk your fingers. There's one twist to making this bowl look as if it's kind of, you can either, with this, put it like this, you can either leave it square or make it look as if it's tapered inwards like this one. So since these blanks were just cut out roughly, they were not precisely cut out. So if you want to now be precise about it, this disc is exactly not 100 but 96 millimeter diameter. 96. So once we start sanding, to make sure that we're not sanding, to make sure that we're sanding evenly, bring this disc up and make a mark here. Not as much material there. Make a mark there. So if we were going to stand absolutely square, we'd take that material away. If we wanted to make a square bowl, we would go for this guideline of 140, because remember it's 141. We want to make a slightly curved bowl. So we're only going to go 130 mil corner to corner. And this is another disc. When the corners, I have the 4 corners marked accurately in red, right? So kind of judge it. So we can get rid of all of that, and the target mark is at the red indicator. High precision. Can you see these marks? So whenever, well, I'll sand a couple of sides. I don't want, what's the situation about dust? Is it okay to sand?
Yes.
Well, we will sand down to that point, leave that point alone, and down to that point there. So it's only a matter of millimeters you're taking off. But it makes a huge difference to the shape of the thing. But just with the sound of this. If you want a square plate, you go in square. But we want a plate that looks slightly oval. So we point it in like that. And we sand away until we hit that point in, that point, but leave that point off. And this sorry about the dust. And that is what we do. And that while sanding, alters the shape. Alters the shape of your dish from looking square to looking artistic. It doesn't take much. You're only sanding off a few millimeter, but it does make that one that I made just left totally square. That's okay. But if you sand away the corners, it gives you a different dish, different effect. That's how's the time going, Pat?
It's happening on the side.
Well, the only thing that I didn't show you that I did want to show you was how sharpening a square, but it needs a platform. So, say a negative rake scraper, that's 15 degrees cut along the top, and that's 60 degrees roughly on the bottom. So that gives you an included angle of 75. So the bird doesn't last long. I think the top edge is, you get a better bird if the top edges get polished. So to make sure that the bird is all gone, this piece of gear I use for another job. Whenever the skew chisel comes off that grinder, I hold it, and I hold it in this way with a drop of metal polish. This is an abrasive. If you want to take scratches, well, it used to be if you want to take scratches out of your car. Not sure whether it works now or not. So I just So once the skew comes off the grinder, then hold it. It's the only tool I hold. And just let the head spin like that. Go to the other side. And that leaves you with that.
What's the surface on that?
That's just a piece of leather. Piece of leather. So we end up with. And if the screw is not sharp, you end up with a screw that is razor sharp. It is razor sharp. The only other thing I use this wheel for is to make sure the burr is gone from the top of these negative edge grippers. And the first of these negative edge grippers I bought was a sorbet one. That was that one there. Sorbet, and this is. All my tools are old, so I don't know whether Sorbet still sell this or not, but whenever I got this the top edge was polished. So I thought, maybe that's got something to do with keeping on a good burr. So again, polish, get rid of the old burr. Get rid of the old burr and keep the top edge polished. And then go to the grinder. No more than 4 passes. If you've got a burr, you run a pencil over it. You can see, whenever you run a pencil over it, it takes the lead off the pencil. So that tool has got, you can feel it. Okay. Well, if you want to demonstrate it, look, there's a burr on there. There it is. So that's that only red CBN wheel basically sharpens everything that I've got. Thank you for your attention. Any questions about anything? More than happy to answer them. It's been a pleasure coming here. Thank you very much.
Thanks for watching, and don't forget to like and subscribe. See you in the next one. Bye.